Let's take a look at today's problem. You are given a 2D array called points, where each element represents the coordinates of a point on the Cartesian plane. Your task is to count how many unique horizontal trapezoids can be formed using any 4 distinct points from this list. A horizontal trapezoid is defined as a convex quadrilateral that has at least one pair of horizontal sides, which means the sides must be parallel to the x-axis. 2 lines are horizontal and parallel if and only if they share the same slope, which in this case is 0. Your job is to determine how many such trapezoids can be formed, and because the number could be very large, you must return the answer modulo 1,000,007. Here's an example to make it clear. If the input points are 1, 0, 2, 0, 3, 0, 2, 2, and 3, 2, the output is 3. There are exactly 3 different ways to pick 4 points that form a valid horizontal trapezoid. 1. Using 1, 0, 2, 0, 3, 2, and 2, 2. 2. Using 2, 0, 3, 0, 3, 2, and 2, 2. And 3. Using 1, 0, 3, 0, 3, 2, and 2, 2. That's the complete problem. Now let's dive into how to solve it efficiently. Now let's break down the final code solution and understand exactly how it works. We start by defining our function count trapezoids, and we set our modulo value to 1,000,007, since the problem requires us to return the answer under this modulus. The first major step is counting how many points lie on each horizontal line. We loop through every point, extract its y-coordinate, and keep a frequency count. This tells us how many points share the same y-value, in other words, how many points lie on the same horizontal level. Next, for each y-level, we calculate how many horizontal pairs we can form. If a level has n points, then the number of ways to choose 2 of them is n choose 2, which is n times n1 divided by 2. If a level has fewer than 2 points, it can't form a pair, so we simply append 0. If fewer than 2 y-levels have at least one pair, then it's impossible to form a trapezoid. Because a horizontal trapezoid requires 2 horizontal sides, one from each level. In that case, we return 0 immediately. Otherwise, we move on to the core computation. We compute 2 things. S, the sum of all pair counts. S2, the sum of the squares of these pair counts. Now here's the clever trick. To count the number of trapezoids, we need to combine pairs from different y-levels. Mathematically, the number of all distinct combinations of pairs from different levels is s squared minus s2 divided by 2. This formula automatically accounts for all unique combinations without double counting. Since division isn't straightforward under a modulo, we multiply by the modular inverse of 2, that's what pow 2 mod does. Finally, we return the answer. So in summary, we grouped points by y-coordinate, figured out how many horizontal pairs each group creates, used a neat combinatorial formula to combine pairs across different levels, and returned the total number of horizontal trapezoids. This turns a potentially huge brute force problem into a clean, efficient O(n) solution. Alright, now that we've built the logic and written the code, let's go ahead and submit our solution. We grouped all the points by their y-coordinates, calculated how many horizontal pairs each level can form, and then used a neat combinatorial formula to count all possible trapezoids across different y-levels. The solution runs in linear time, uses only a single pass to gather counts, and avoids all brute force checks of 4 points, making it efficient even for inputs as large as 100,000 points. Let's hit submit. And there we go, accepted. Our code successfully handles all edge cases, performs the modulo operations correctly, and efficiently computes the number of unique horizontal trapezoids. If you found this walkthrough helpful, make sure to like the video, subscribe for more daily LeetCode explanations, and let me know in the comments which problem you want me to solve next. See you in the next one.